Hi, my name is Mark Knezovich, and this video is to showcase my music machine project for SER202 Programming for Embedded Systems Trimester 2 at Deakin University. Okay, so there were some minimum requirements for the project. It had to be standalone, which you can see it is. It has to be all-in-one, enclosed, neat, portable, with no connections to the computer and no loose wires, as you can see. That is the case. Just some about the basic construction of the device. So here at the back is the on-off switch. The drum kit I bought online from eBay. So I used most of the kit with except for two extra drums. So I used part of the original drum kit stand to mount the drum to the box. The servo mount is 3D printed, which I designed on Inventor Studio and printed on my 3D printer. There's two MG995 servos here and here. The box I bought from JCar for about $6.95. Inside the box are the batteries, the Arduino Atmega 2560 board. Other parts is a LED here that lights up when I turn the power on. There's a keypad here for interface, the 10 LED barograph, and in the back corner here the buzzer is mounted. Okay, so now just to run through the functions. Buttons 1 to 3 are the tunes 1, 2 and 3. Buttons 4, 5 and 6 isolate different functions, and we'll talk about 7, 8, 9 in a moment. So by way of demonstration, button 1 plays tune 1, and the default is that all three things play. The buzzer plays, the LED plays, and the servos play. I'll turn it on first. And if I push button 2, it plays the second tune. And button 3 plays tune 3. Now another part of the requirement is we had to be able to disable each of the buzzer, the LED and the drum. So button 4 disables the buzzer, and I'll demonstrate that in tune 1. Button 5 disables the drum, and I'll demonstrate that through tune 2. And button 6 disables the LED, and I will demonstrate that through tune 3. So that part of it fulfills the basic requirement. As an X factor, I've added the symbol, and through buttons 7, 8 and 9 we have some different functions. So if I was to press button 7 and play tune 1, the front servo will play the cymbal and the rear cymbal will play the drum. And if I was to press button 8, and we'll demonstrate through tune 2, the rear servo will now play the cymbal and the front servo will play the drum. And if I was to press button 9, and we'll demonstrate through tune 3, both drumsticks will hit the servo, hit the cymbal. And because that's operating through an interrupt, if I was, for example, to press button 9 and then button 6, it will now play the drum and the buzzer, but not the LEDs, and we'll do that through tune 2. And that concludes the demonstration aspect of the video, and I will now talk about the code. Okay, so now let's take a look at the code. Starting at the very top, we've got some global variables. These ones here are for the keypad, these ones for the LED, these ones for the servo, that one's part of the keypad. This part here is the serial communications. It's not used for the running of the actual music machine, it was just used during the testing phase to test the keypad. Could have taken it out. Further on in the setup function, this sets up the columns, this sets up the rows. Then we've setting up all our timers for our interrupts, our buzzer and our servos. So just looking a little more closely, this CLI function just clears all the interrupts in case there's some unwanted interrupts running in the background. We're using timer 5 for our interrupt. We're using timer 1 for the buzzer. DDRB just sets bit. This part here sets bit 7 of port B to 1, which makes it an output pin. That's connected to the buzzer. As I mentioned, that's the timer set up for the buzzer. Same thing here, setting up the pins connected to the servos as outputs, setting up the timers for the servos, setting up the pins connected to the LEDs as outputs, so that everywhere there's a 1, that's set up as an output pin. I've used 3 ports just because of the way the pins are on the board. It was just easier to use all of port C, 1 of port D and 1 of port G. And then we've got our keypad function. So in this function here, the interrupt is running and it's scanning through waiting for an input. So this part here is looking for an input down column 1. This part here is looking for an input down column 2. And this part is looking for an input down column 3. Then I've got my 3 tune functions. So here we're looking at tune 1. Some variables here. So in my arrays I've got no hard codes. So here that's all easily adjustable. My for loops for those arrays for the servo and the buzzer. And here we've got the LEDs. So for example, when the array is equal to low, these LEDs are turned on for the same duration of note low, and then they're turned off. Same goes for medium and high. And then I've got a function at the very bottom of each tune called reset, and I'll just scroll down. So tunes 2 and 3 follow the same pattern, and then we get to the reset function. So at the end of each tune, timers 1, 3 and 4, buzzer, servo front, servo rear are all set to 0, so they stop playing. And these 3 lines here turn all the LEDs off by setting those ones from 1s to 0s. And then these lines here turn everything back on again, so these 3 turn each of those ports and pins connected to the LEDs back to outputs. This just resets the top value of the servo timers, that one for the servo timer and buzzers, and this one here just resets the values of the servo positions because they might have changed depending on which buttons we pushed. And then we've got the function for the button switch case buttons, sorry for the button switch. So what happens here is, for example, when button 1 is pushed, and we know that because the previous function detects that, it then calls switch case 1. So first thing that happens when the button is pushed, it clears the interrupt, so the interrupt stops running. If I was running the serial monitor, it would print this statement here, switch S1. It runs through, calls function tune 1, plays whatever that is, resets the keypad button back to 0 again, and this turns the interrupt back on, and it's waiting for another input from the user, and this line here stops the case. And then, so if I was to push any other button, 2, 3, right up to 9, it would just follow the instructions written within those. So that's the program. Actually, we'll just scroll a bit further down to the loop function. So the only thing in the loop function I have is the button switch, which is the switch case function. So it just loops through looking for an input there, and whatever button is pushed is what instructions are given to the controller to play the tune or parts thereof. Well, I hope you enjoyed the video. I really enjoyed making this project, and thanks for your time.